Okay, this section we're going to talk about arc lengths. Given a curve or a portion of a curve, say here's a curve from here to here. This portion, how long is the arc length? So what we want to do is we want to find out, like always, we want to find out what a little piece of the arc looks like, or what's the value or the length of a little piece of the arc. Suppose we just want to find this little piece. If you think it's too big, fine, it's too big. Make it smaller. And what we're going to do is we're going to assume that that's a straight line. And maybe now I should have just said what I said. Maybe it doesn't look like a straight line, it's too curvy. Well, make it shorter. You make it short enough, it'll look like a straight line. And to find the length of a straight line, we call Pythagoras in. We'll call the bottom length delta x, and the height delta y, and maybe we'll call L for the length of the straight line. So that little piece, we'll call it delta L. So we know that delta L, delta L squared is equal to delta x squared plus delta y squared. And if I divide the left side by delta x squared and also multiply it by delta x squared, I really just multiplied by 1, because this over that is 1. So this is the same as delta x over delta x all squared plus delta y over delta x all squared, and this whole mess gets multiplied by delta x squared. Well, that's delta L squared. I don't want delta L squared, I want delta L. So I take the square root of both sides. Now remember, if you have a product like A times B and you take the square root, you can take the square root of A and B separately and then multiply. Here's my A, here's my B. I get the square root of course, delta x over delta x is 1, and when you square it, it's still 1, plus delta y over delta x all squared times delta x. Now, in the limit, delta y over delta x, that just becomes dy dx, also known as f prime of x. And in the limit, delta x becomes dx. And if we add these all up, we add up all the delta x, delta l's, we get just L, and we have to integrate. When you add up a lot of pieces, you integrate. And you integrate from A to B. And that's the arc length formula. Anytime you forget it, go back to Pythagoras. I can forget this anytime I want. And there have been times I've forgotten it. And I just go and I rederive it. That's the formula. So now that we have the formula, and we don't have to worry about, say, on an exam, oh my, I forgot the formula. Well, just rederive it. So now let's do a concrete example. Suppose you have this function. You have that f of x is equal to x cubed over 6 plus 1 over 2x. So now we need to find the derivative. Well, the derivative will be, the 6 just stays there for the first term. Derivative of x cubed is 3x squared. Fine, that reduces to that. Now, the derivative of a half x. The derivative of a half x. Well, remember, that's 1/2 times 1 over x. So taking the derivative of a constant times a function, there's a rule that says that you can just keep the constant and take the derivative of the function, 1 over x. But 1 over x is the same as x to the negative 1. And when you take the derivative of that, you bring down the power, negative 1. You make the new power 1 less. And you end up with negative 1 over x squared. Or, multiplying everything out, negative 1 over 2x squared. Negative 1 over 2x squared. That is, the derivative is x squared over 2 minus, let me put that here. The derivative is x squared over 2 minus 1 over 2x squared. You can factor out the half, and you'll get x squared minus 1 over x squared. Okay, let's get rid of this. So now we have the derivative, and we know the formula for arc length. Oh, I did leave out one thing, so sorry. We want to find the arc length between negative a half and 2. And we want to find the arc length between negative a half and 2. Okay, so we have our derivative, and we have to square it and then add it to 1. Well, if I square it, f prime of x quantity squared. Remember, if you have one thing times another and you square the whole thing, you have to square each piece separately. You have a times b and you want to square it, you get a squared times b squared. You square each piece. Well, when I square half, I get a quarter. And when you square what's inside the bracket, you get the first squared, which is, I like to call this the first and that the second. The second being 1 over x squared. You get the first squared, which is x to the 4th. You get x squared squared, which is x to the 4th, minus 2 times the first times the second. But that's just 1 because the x squares cancel. So it's minus 2. It's minus 2 times 1, which is minus 2. Plus, you get the second squared, which is 1 over x to the 4th. Okay, and 2 times 1 is 2, so I'll erase the times 1. Okay, we're getting closer. We have the derivative squared, but we don't really want that either. We want 1 plus the derivative squared. We want 1 plus the derivative squared. So let's calculate it. 1 plus f prime of x squared. Think of the 1 as 4 over 4. Plus 1/4 times this mess. Okay. Now I can factor out the quarter. I can factor out the 1/4. I can factor out the 4 in the bottom. It's 1/4. It's x squared minus 2 plus 4, which is plus 2, plus 1 over x to the 4th. When I factor out the quarter, I'm left with 4 plus x squared minus 2 plus 1 over x to the 4th. And I don't mean to say x squared, sorry. I've been meaning to say x to the 4th. And 4 minus 2 is plus 2. And that's just what I wrote. Okay. Now, the nice thing about whenever these problems are going to work out, 1 plus the derivative square itself must be a perfect square. Or at least the quarter doesn't have to be a perfect square. This would have to be. And you know what it is? It's x squared plus 1 over x squared squared. That's what this is. You have to be able to do that. When I square that, I get x to the 4th. When I multiply these two, I get 1. But I'm supposed to multiply it by 2. Whenever you have a sum and you square it, you get the first squared plus 2 times the first times the second, which in this case is AB, plus you get the second squared. Well, the first squared is x to the 4th. When I multiply these two, I get 1. But then I have to multiply that result by 2. 2 times 1 is 2. Plus, when I square 1 over x squared, I get 1 over x to the 4th. Okay. So we have the 1 plus the derivative squared. Now, one of the tricky things you have to realize is the following. A lot of people get caught up here. They think if you have x squared and you take the square root, you get x. You get back this. That's not true. If I replace x with -3, when I square -3, I get 9. When I take the square root of 9, I get 3. They're not the same. They're not the same. What you get back is the absolute value of what you're squaring. If somebody asks you what is 3x minus 4 all squared square root, it's the absolute value of that. And remember, if this is positive, then the absolute value will just be that. The absolute value of 7 is 7. The absolute value of 9 is 9. If this is positive, then the absolute value will just be 3x minus 4. If it's positive. If it's negative, it won't be that. Think about what it should be. So now, we have to integrate. To find our arc length, we have to integrate, remember it was from 1/2 to 2 of the square root of this. That is the square root of that. Well, what is the square root of this? Remember, if you have the square root of a product, you can take the square root of A times the square root of B. Well, here's my A 1/4, and what's in the bracket squared, that's my B. The square root of 1/4 I know is 1/2 times the square root of x squared plus 1 over x squared squared. I want to say it's the absolute value of this. But you know what? This is always positive. X squared is always positive. 1 over x squared is always positive. And if x is bigger than 0, it won't be 0. If you're bigger than 0 and you get squared, you're positive. If you're bigger than 0 and you get squared, you're positive. 1 divided by a positive number is positive. You add two positive numbers, it's positive. So you don't need the absolute value bars. It's this. 1 over x squared dx. Okay, now after all this work, and it was a lot, after all this work, now we can integrate. We took the derivative, and then we spent the long, so that was calculus, and then an awful lot of algebra. We had to figure out what the derivative squared was, add 1 to it, and then take the square root of it. Okay, now, first thing I'll say is, let's bring the half in front. So it's 1/2 the integral of x squared plus, I'll rewrite that as x to the -2 dx, from 1/2 to the number 2. So the 1/2, it just stays in front. The integral of x squared is x cubed over 3 plus the integral of this. You add 1 to the power, you get -1, then you divide by -1. And you evaluate from 1/2 to 2. But let's just clean up that second term. X cubed over 3. The x to the -1 can go in the bottom as x. And then adding, this is negative. Adding that's a negative quantity. Adding a negative quantity is just same as taking away the positive. Adding x to the negative 1 over negative 1. This is the same as adding, well, that fraction is negative and it's 1 over x. Adding negative 1 over x is the same as taking away 1 over x. And that's just what I did. And this gets integrated from 1/2 to 2, or evaluated from 1/2 to 2. We're done integrating. Now we evaluate. The 1/2 I'm going to put in front of everything. Get in that habit. That way you don't have to deal with the half. It's 1/2. Big brackets. First I plug in here. I plug in 2 for x. I get 2 cubed over 3 minus 1 over 2. Brackets minus new brackets. Now wherever I see x, I plug in a half. I have a half cubed over 3 minus 1 over a half. Here's my good old half in front. 2 cubed is 8. I have 8/3 minus a half. Minus. A half cubed is an eighth. Then you divide it by 3. That becomes 1 over 24. Minus. A half goes into 1 2 times. Think about that. Okay, and there it is. We're down to arithmetic now. The common denominator is 24. Let's go to the top, finish this up. The half stays out in front. 1/2. In fact, okay, 1/2. Now, I want to write everything to 24 on the bottom. 8 over 3, I multiply the top and bottom by 8, I get 64 over 23. Minus, here, I multiply top and bottom by 12. So the bottom is 24. 2 times 12 is 24. 1 times 12 is 12. Minus. The next fraction is 1 over 24. There's my 24 in the bottom. Here, this is like 2 over 1. Well, you want to write 2 with the 24 in the bottom. This is how you do it. 24 times 2, 48. Minus 48 over 24. Okay, now we have a common denominator. We can surely clean this up. Over 24. 64 minus 12, 52, minus 1 minus 48 is negative 47. And you have 48 on the bottom. 2 times 24 is 48. And the 1 you could ignore. Multiplying the numerator by 1 won't do anything. 52 minus negative 47 is 99. Okay, and if you want to multiply the 99 by 1, go for it. It'll still be 99. The last thing is, both of these numbers are on the 3 times table. 99, for example, is 3 times 33. And 48 is 3 times 16. The 3's cancel, and there's your answer. 33 over 18 units. That's the length. If it was in feet, it's in feet. If it's in centimeters, that's what it is. 33 over 18 centimeters. Let's try another one. Suppose you have, so now I'm just going to point out, if the arc length is 1 minus, now another way of saying f prime of x is dy dx squared dx. That's one way of calculating the arc length. Well, that's one formula. But maybe it's not easy to find dy dx. You can interchange, that is, you can interchange dy and dx. What if you have dx over dy squared dy? Okay, you can interchange dx and dy. Go back to the original proof I gave and argue that through. Okay, so now when you would use that is if it was hard to find dy dx. If it's y and it's a function of x, then it's easy to find dy dx. But if you can solve for x in terms of y, why not do dx dy? Okay, and that's what's going to come up right now. Suppose you were told that x minus y minus 1 cubed is equal to x squared. And you want to find the arc length on 0, say to 8. So now, we can solve this for y. We can take the cube root of both sides, and then we would get y minus 1 is x squared to the third, which is x to the 2/3, and then add 1. That's probably not a crazy way of doing it. However, let's try to use the second formula for this problem. Let's just take the square root of both sides. We know then that x is equal to plus or minus. If x squared equals anything, then x equals plus or minus the square root of that anything, which is y minus 1 to the 3/2, plus minus. Okay, so we have x. Let us find dx dy. Bring down the constant. You get plus minus 3/2. Y to the negative 1. Make the new power 1 less. 3/2 is 1.5. Make it 1 less. You just get a half, which is what I put. And the derivative of inside is 1. So that's dx dy. Don't worry about the plus or the minus, because the formula asks us to square it. So plus or minus, when you square it, is plus. 3 over 2 squared is 9/4. And this squared is going to be y minus 1. Now let me just talk about that. I said earlier, if you square x and then you take the square root, you'll get the absolute value of x back. But if you take the square root of x first and then square it, well, it's understood that x is positive. You can't be taking the square root of a negative number, so then you get back x. Remember, this piece here is the square root of y minus 1. When you square that, you get back y minus 1. Now, I want 1 plus the derivative squared. 1 plus. Now, think of the one that I just wrote on the right-hand side as 4 over 4. It's not always 4 over 4, but we keep ending up with problems with 4. It's 4 over 4 plus 9y over 4 minus 9 over 4. And everything's over 4. We have 9y. You take away 9 and you add 4. You took away 5. That's what we get. That's exactly what we get for 1 plus the derivative squared. We get this. And then we integrate. So we want to integrate the square root of this here, which is also known as 9y minus 5 over 4 dy. But now, the question is, what do we integrate from? Initially, this was the beginning problem. Given this function, find the arc length on 0, 8. These are understood to be x values. Okay? Those are understood to be x values. We're integrating with respect to y. We're integrating with respect to y. So I need to go and find the y values. We know that x squared is y minus 1 cubed. When x is 0, 0 squared is 0. Well, what do you cube to get 0? 0. This must be 0. That happens only when y is 1. So instead of the lower limit being 0, it's going to be 1. Okay, now 8. We know that x squared, in this case x is 8, 8 squared is y minus 1 cubed. 64 is y minus 1 cubed. But 64 is 4 cubed. It is y minus 1. This must be 4. That means y is 5. 5 minus 1 is 4. Y is 5. Y must be 5. So I integrate from 1 to 5. You need to change the limits. Again, this here was the beginning problem. They said find the arc length of the curve y minus 1 cubed equal x squared on 0, 8. It's always understood those are x values. That's big. You caught up in that? That is, if you don't know that, you're going to mess up. And there's nothing to understand. It's just convention. Those are x values. It isn't like, oh my, I'm so bad in math, I didn't know that. No, no, no. That's not math. That's just a rule. Just like you separate a list with commas whenever they say find the arc length on AB, they mean from x equals A to x equals B. Okay. Square root of 4 is 2. I'm going to pull out the 2. And of course the 2 is in the bottom because the 4 was. So now we need to integrate 9y minus 5 dy. That's a u substitution. If we let u equal 9y minus 5, then du will be 9y dy. So if I sneak in a y here, a 9 here, and I counter by putting a 9 in the bottom, this piece here is du. It says so. This equal sign has many meanings. One meaning, excuse me. If u is 9y minus 5, then du would just be 9 dy. Big mistake. This symbol right here says whenever you see this, you can replace it with that. And I just did. I saw 9 dy, I replaced it with du. So now I have 1 over 18, the integral of, this piece here is du, and this is u. Square root of u means u to the half. But that's a simple integral now. I add 1 to this power, which is 3 halves, and then I divide by 3 over 2. Coincidentally, 2 goes into 18 9 times. 1 times u to the 3 halves is u to the 3 halves, and 9 times 3 is 27. Now why don't we just substitute back? Instead of u to the 3 halves over 27, instead of u, and I don't guess, I look back at what I called u. So many students will guess, oh, I think it was 9y minus 14. No. Maybe you're right, maybe you're wrong. Go back and read it. It says, u is 9y minus 5. And we're integrating from 1 to 5. Well, when you plug 5 in, 9 times 5 is 45, minus 5 is 40. 40 to the 3 halves over 27 minus, you plug 1 in. 9 times 1 is 9, minus 5 is 4 to the 3 halves over 27. So everything's over 27. And 40 to the 3 halves is 4 to the 3 halves times 10 to the 3 halves minus 4 to the 3 halves. I'm setting it up so I can factor out 4 to the 3 halves. Four to the 3 halves times 10 to the 3 halves minus 1 over 27. Okay, couple of more steps maybe. Let's find out what 4 to the 3 halves equals. 4 to the 3 halves, this right here. 4 to the 3 halves. This asks two questions. Rather simple questions, but you have to know it. It's asking, what times itself this number of times gives you that number? What times itself 2 times gives you 4? The answer is 2. And then you have to cube that answer. 2 cubed is 8. So we get 8 times 10 to the 3 halves minus 1 over 27. And you can try as long as you want. You're not going to know what to multiply, but you should check. What times itself 2 times gives you 10? And the answer is the square root of 5, but it's not a friendly answer. And there's your answer. The long problems, but you have to be able to do them. Again, this particular problem, you didn't have to do it as dy's. But if you do, you're going to have to change the interval from 0 to x equals 0 to x equals 8 to the corresponding y limits. Okay, so suppose we're given that y is equal to, or f of x is equal to x minus 0.005 x squared, and the interval is going to be 0 to 200. It's understood that those are x values. Why is it understood? I don't understand that. By convention. It just is. Okay, so then y prime is 1 minus 0.01x. Which is the same as 1 minus x over 100. 0.01 is 100th. 100th times x is x over 100. Now, y prime squared, you have to learn how to square. You get the 1 squared, which is 1, minus, because there's a minus here, 2 times this times that. This times that should be first grade. Why? Because we're multiplying by 1. We get x over 100, plus the second squared. X squared over 100 squared. What's 100 times 100? Well, 1 times 1 is 1. 1, 2, 3, 4 zeros. 10,000. It's x over 10,000. And this is just 2x over 100, which is x over 50. Is 1 minus x over 50 plus x squared over 10,000. we want 1 plus that. We want 1 plus y prime squared. Well, if you add 1 to that 1, you'll get 2. 2 minus x over 500 plus x squared over 10,000. But this, believe it or not, is going to be a perfect square. That's going to be, let's see if this is going to work. X over 100 Okay, what you're going to have to do here is the following, sorry. Okay, so what you're going to have to do here is the arc length L is equal to the square root of, I'll just say the x squared term first. Like I said, at least I'm pretty sure I said, this is only going to work from 0 to 200. This is only going to work if 1 plus dy dx or 1 plus dx dy is a perfect square. What you're going to have to do is approximate the arc length of y equals x minus 0.005x squared on 0 to, say, using Simpson's rule. Using Simpson's rule. Okay, so now you're going to have to approximate this with Simpson's rule. And you probably should use n equals, I don't know, 50. N equals 10 would be good. Okay, so whenever this is not a perfect square, you're going to have to approximate. Okay, it's not always going to work out to be a nice, clean problem. So when it's not a perfect square, you use a trapezoidal rule, you use Simpson's rule, you use some kind of a rule, approximation rule. Use a numerical method. Now, suppose I give you 2 points, x1, y1, and x2, y2. Say that's x1, x2, and that's x2, y2. Now I ask you to find the length between the 2 points. Well, what you can think of what's going on is, here's a line, and I'm just asking you to find the length of the left part of the line. The length from this point to that point. Right. Now, we know that when it comes to a straight line, the derivative is the slope. And the slope of our line is y2 minus y1 over x2 minus x1. And the derivative squared would be y2 minus y1 squared over x2 minus x1 squared. And if I add 1 to the left, I have to add 1 to the right side. So we need to clean this up and then integrate from x1 to x2. Just want to clean that up. So let us get a common denominator. How about x2? How about writing the 1 as x2 minus x1 squared over x2 minus x1 squared plus, well, the second fraction has the same denominator, x2 minus x1 squared. Let's use that fact. y2 minus y1 squared. Okay, so that's 1 plus f prime squared. Now we want to integrate the square root of that times dx. Now everything above all of this, all of that is a constant. We're just integrating dx. So we get our constant, x2 minus x1 squared plus y2 minus y1 squared. And you know what? The square root of the bottom is just x2 minus x1. I guess we could say at the beginning, assume x2 is bigger than x1. So this is positive, and the absolute value will just be x2 minus x1. Integral of dx is just x, and we're going from x1 to x2. So factoring out my constant, x2 minus x1 squared plus y2 minus y1 squared over x2 minus x1. When I plug in x2 for x, I get x2. And when I plug x1 in, I get x1. And I subtract them. x2 minus x1. And the amazing thing is that cancels out. And what survived, distance formula, folks. Distance formula, there it is. Square root of x2 minus x1 squared plus y2 minus y1 squared. So it even works for lines. A line is a curve. Some people will say, no, it's not a curve. Of course it is. It's a straight curve. It's a special curve. It's like saying an equilateral triangle is not isosceles. An isosceles triangle is not a triangle that has exactly two sides equal. An isosceles triangle is a triangle that has two sides equal. Well, this triangle, all sides are equal. Yeah, it has two sides equal. It has three sides equal as well. It has two sides equal. It's isosceles. Let's try one more. I'll give you the function, and I'll give you the interval. Y equals x to the 3 halves minus 1. And we want to find the arc length of that from 0 to 4. Well, the derivative is 3 over 2 x to the half. Okay, and the derivative squared will be 9/4 x. So 1 plus the derivative squared will be 1 plus 9/4 x. But that's 4 plus 9x over 4. 4 over 4 is 1, and this is 9x over 4, right there. So what we want is the integral, so the arc length equals the integral from 0 to 4 of the square root of 4 plus 9x over 4 dx. But I know the square root of 4, it's 2, so I pull it out. So it's the integral of 4 plus 9x dx. And I'll let u equal 4 plus 9x. If I let u equal 4 plus 9x, then du is 9 dx. So I need to put in a 9, and once I do that, that's du. It says so. Whenever I see 9x, I can write du. But if I put a 9 in the numerator, I have to put a 9 in the denominator in front. So then this integral becomes 1 over 18, the integral of u to the half, square root means half, times du. But that's not a bad integral. I can do that. I add 1 to that power. I get u to the 3/2. Then I divide by 3 over 2. And 2 goes into 18 9 times. So I get u to the 3/2 over 27. Now, there's a couple of ways to proceed from here. Last time we had a similar problem. We converted a u back to x's, but now let's keep the u's u's. We have u to the 3/2 over 27. We have to find the limit. Well, remember, it started with x equals 0. If x equals 0, then u is 4 plus 9 times 0, or 4. So lower limit is 4. And if x is 4, then u equals 4 plus 9 times 4, that's 36. 4 plus 36 is 40. 40. So then I get 40 to the 3/2 minus 4 to the 3/2 over 27. This looks like it looks very similar to a problem that we kind of just did, doesn't it? Okay. So 40 is 4 times 10. So 40 to the 3/2 is just what I wrote, minus 4 to the 3/2 over 27. I factor out 4 to the 3/2, but that's 8. Top right corner, 4 to the 3/2. What times itself 2 times gives you 4? 2. Cube the 2. You get 8. So then you have 10 to the 3/2, take away 1, over 27. And there's your answer. Okay, I hope you understood this. Good luck with it.